Okay, this is just some very basics about materials and categories of processes. Um, in industrial technology, we have a whole nother course that goes into materials, and so this is just some introductory stuff. We won't be getting too deep into the weeds on materials. Okay, lots of categories: um, metal, plastic, ceramics, composites. Um, and as they have wood there under a plastic, you'll see that wood is actually a natural plastic. Metals, your basics are steel and um, or cast iron. Cast iron is not the same as steel. Iron and steel, iron is the element in steel, but it is not the only thing that is in there. Um, you can have, when you mix carbon with the iron, you get steel, and you have low carbon steel and high carbon steel. And low carbon has about 0.25% carbon by weight in it. High carbon steel has about 0.85% carbon in the mixture, and high carbon steel is much harder than low carbon steel, and you have different varieties of plain carbon steel. You also have stainless steels. Um, Other types of metal include aluminum and brass or bronze, which are copper alloys. Alloys. You also have um, basically iron alloys that will have mostly iron, but some chromium and some molybdenum, which is called chrome moly. And it's basically any mixture of metals in the transition metal area of the periodic table. I may or may not get into that a little bit further in this class, um, but it is covered in the industrial materials class for industrial technology majors. Some of you have had that course already. Metals are recyclable. We're going to see that some of the materials, not so much. Okay, other category is plastics. Plastics are artificial plastics are made with long chains of carbon atoms, mostly hooked up with hydrogen. Carbon and hydrogen creates a monomer of polyethylene, um, which is the backbone, but there are other things. You replace some of those hydrogens with chlorines, you get polyvinyl chloride. Other ways you can make nylon, you can make all these things, but they all have the backbone of a large chain of carbon atoms connected together. Now, in artificial plastics, you have two categories. You have thermoplastics and thermosets. The thermoplastics are remeltable, reusable, recyclable. You can usually mold them or cast them. Injection molding, we'll be talking about some of these kind of processes later on in the course. Thermosets are plastics that are not remeltable. And if you don't have much experience with plastics, if you, on the little question about how much knowledge you had of plastics, is the only thing you knew is melting a fork over a fire, that fork over a campfire is obviously a thermoplastic. But there's a big category of plastics that are not remeltable. And look inside your car engine area, a lot of plastics in there, and they have to be sturdy enough not to be remelted because they are thermosets. And the thermosets have been around for a long time. You usually machine them, although you can mold them. And as I said, woods are a natural plastic. Why they're a natural plastic is they have that carbon chain, carbon and hydrogen, but only 7 carbon atoms long. natural plastics have 30 or more carbon atoms in each individual chain. Wood only has 7. That's the cellulose. And then it has some more broken ones of 3 and 4 carbon atom chains. That's the hemicellulose. Thing about wood is because it grows, it's directional. You have the grain that runs in one direction or the other. You have 2 different types of wood. Hardwoods, which come from trees that have leaves on them, and those are fancy furniture woods like walnut, oak, cherry, hickory. Well, actually, hickory's not so much a furniture wood as that's what you make hammer handles out of. The softwoods are from trees that have needles on it. Those are the pines, firs, cedars, and that's mostly used in construction. Another category of materials is ceramics, and I'm not talking about teacups and plates and tableware. That's not industrial ceramics. Industrial ceramics include bricks and concrete and glass. But for manufacturing, there are some other ceramics like aluminum oxide, which has become abrasives and cutting tools for machining operations, which we'll talk about in just a second. The composites, they're mixtures of other types. Generally, you're laminating materials or combined in some other ways. You can think of a grinding wheel as a composite. It has you're putting a lot of stuff together and kind of gluing it together, and you can't separate just the grinding media from the media that holds it together. The most common composite is fiberglass, and you put now plastic fibers, but you embed them in a plastic resin, and you have fiberglass, and you can shape it. You've heard carbon fiber, and that's really the new skin to make airplanes. Very strong, very lightweight. Okay, let's go back and review for just a second the definition of manufacturing. We're going to apply knowledge, take raw materials to turn them into products. We're going to use machines and equipment, and we're going to follow processes. We're going to talk a little bit about some processes, and one overall process is kind of the systems module, systems outlook, and that is that you've got your input, you got your process, you got your output, and then you got feedback going back to see if you got it right. And that loop is used a lot to figure out how to define a process and improve it. And a few other little terms to try to define. Production is the broader process, and it could be production of ore, the raw materials from the ore, from the mines. You wouldn't really call that manufacturing. Or the distribution of the finished goods. That's not really manufacturing. Other non-tangible products, banking would be production. But manufacturing is the part of these production issues if it involves making a product. If you're starting from some sort of raw stock and ending with a product on the shelf. And as I mentioned previously, you have consumer goods, and then you have industrial or producer goods. There's a couple things just to be able to get to that raw stock that you would start with in a manufacturing process. You're going to start with ore or timber, but maybe ore, and then process it through some. It varies with the different types of metal. You process aluminum differently than you process process iron, you process copper differently than you do either of the other two. So, but you have to process it in some way, and it ends up getting into a molten state for the metals, and then you cast it, and then you take that casting and turn it into other shapes. And through this process, you'll hear some terms like annealing and hardening or tempering. I'm not going to get much into that, but you can do those processes in later steps also. We may cover that a little bit when we get into welding, because you're looking at heat processes there that could be very useful. Okay, of the processes for taking that raw stock, a bar of metal, whatever, you've got a machining process. It's also called chip removal, because you're actually taking one hard material and ripping out to another material. And we have some basic processes that are chip removal: milling, turning, drilling, grinding, sawing, and there's some readings on this that go into the different ways that the raw stock is done by chip removal. You also have some processes called forming. You have hot forming, and one is forging, which is you get the material super hot and shape a horseshoe, or as you will see, there are massive ways to make really big parts from hot forming through forging. You also have hot rolling. Heat them up and you can roll a piece of steel and shape it into an angle bracket or a channel. You can extrude metals, or you can extrude plastics. Very doable way. There's a few other processes. You have cold forming processes, and that's where you would take sheet metal, bend it, flip it over, do something with it. Cold rolling processes. We'll be going into some of these through the course, but these are just the categories. You got joining processes, and obviously there's welding, which you're probably familiar with. Gas and arc welding. If you're not familiar with it, you know the concept. You're going to learn a lot more about it. But there's also joining processes with fastening as part of a manufacturing process. And there's threaded fasteners, there's rivets, you can fold pieces together. That's how you would make ductwork. You take the sheet metal and you fold it in and of itself, and it creates a joint. And again, there are readings posted for this. You should look at those readings. A couple of terms that you need to make sure you understand, one being finishing and one being assembly. Finishing does not mean you're done with the product. What finishing in manufacturing means is applying a coating, doing something decorative at the end, sanding it, polishing it, etching it, those types of finishes on a piece of material, spraying a lacquer, staining it, whatever. Those are part of a finishing process. Assembly is putting this discrete parts together. That's really all manufacturing is making different discrete parts and hooking them together in the assembly process. So that's generally a whole separate process, and we're not going to spend a lot of time with it, but that is part of it. And also you need to realize, and I just want to mention here, that developing packaging is a huge part of the manufacturing process. You've certainly bought a cell phone or some high dollar electronic component that comes in a package that you have to open up, and it's usually designed for it. The little thing sits in a cradle. There are engineers and technologists who spend their career packaging things. There's a few other things: embossing, electroplating, etching, hot isostatic. Anyway, we're going to be covering some other processes. I'm going to be doing a little report on these different processes, um, and a particular process, it could be end up being very unique to a particular product. Plastics processing, there's generally a similar metal processing for it, but the biggest one in plastics, for plastics, is injection molding, and it's similar to the casting that you'll see in metal working. Um, Extrusions are big in plastics. More processes for machining plastics, chip removal, happens more often than you would think. Um, Out there in the real world, it does happen. The processes for processing wood is you have, basically you have cuts that go with the grain, which is called a rip cut. You have cuts that go across the grain, which is called a cross cut. You route the edges. Generally, you want to shape an edge, or you turn the part on a lathe. And that's one of the things, you're going to be turning some metal parts, or seeing about turning metal parts, but you also turn them on a wood lathe. And